Namaskar, my dear friends. Let us talk about IPM circuit design. So we had seen this particular system circuit design based on intelligent power module that is taken from Mitsubishi IPM. Okay, and the series name is SLIMDIP-S. So many of you have been asking like what are these terminals, all the pin and their like descriptions and how it is the design process follows. So what we'll do is we'll try to understand what is the importance of IPM and what are the different terminals and what is their uses and how the circuit has been designed one by one. Okay. So before that, what we'll try to understand is what is the motivation for IPM and what are the applications. Okay. So as you can see, we have been talking about lot of circuit based on like intelligent power module that is given from lot of like different manufacturers. Like let us talk about like we have Microelectronics, Mitsubishi, Rom Semiconductor, onsemi, Fuji Electric is there. Like so many other companies are there. However, the various applications that if you want to see, we have like electric traction or main inverters, onboard chargers, DC-DC converters, or we have HVAC or climate control for air conditioner, EV charging systems, energy generation and distribution like solar power systems. We have like motor control tools, power supplies. So there are various applications that is there. If you want to talk about like in simplicity form, then simplicity we can take up, let us say slim dip S we want to utilize for. So this is the IPM that we are going to use. So this can be used in your air conditioner, cloth washer, refrigerator, dishwasher, fan, pumps, wherever you want you can utilize them anywhere. Okay. Now what is the motivation for this particular IPM? So as you can see earlier we needed lot of discrete items, like we needed gate drivers, we needed MOSFETs for full bridge circuit. 6 MOSFETs will be needed. We will need like bootstrap diode and capacitors, resistors. So many components will be required to make your discrete solutions for intelligent power module kind of thing. However, all these things are put together in one package, and this is going to give you all in one approach. So this is a single package that is going to do all this particular job. Okay, so this is the benefit of having IPM solution. And why it is preferred is basically because of this reason. As you can see, this particular IPM circuit is having all these 6 MOSFETs. It is nothing but IGBTs are there. So 1 2 3 4 5 6. Then we have gate drivers inbuilt in this. So high like gate driver and low side gate driver. We have inbuilt like bootstrap diodes inside, and these are all these pins that is there. So why don't we do one thing? We will try to understand the pin configuration so that you can have a proper understanding. Of this particular symbol that has been made. Okay. So if you see the application note of this particular IPM, then you will find it out what is the terminal description. Okay, so we have 1A pin, 1B pin. Okay, so it is basically used for internal purpose and there should not be a connection. So as you can see from the circuit, there is no connection for 1A, 1B. Okay, similar to that we have pin number like 2 3 4 5 6 7. So these 6 pins are there: UFS, UFB, VFS, VFB, WFS, WFB. So these are all U phase P side drive supply for ground terminal and positive supply terminal. So B is positive terminal and S is ground terminal. So you can see S is ground terminal, right? So you can see you have UFS, VUFS, VUFB. So this is positive terminal. So this is my positive terminal and this is my ground terminal. So ground is connected. So this is how a complete circuit has been designed, capacitor plus this clamping diode. Okay. Now let us talk about other parts. We have UP, VP, WP and UN, VN, WN. So this UP, VP, WP is nothing but U phase P side control input, and U phase N side control input. So it is high side voltage, high side gate driver, and this is low side gate driver. Okay. So this is the place where you will be giving the PWM from your controller card. All right. Now coming back to the other part, we have VPN and VN1N. Okay, VP1 and VN1. So this is nothing but P side control supply positive terminal and N side control side positive terminal. So basically this is 15-volt power supply that it will be given. So you can see the circuit, what is happening. UP, VP, WP and UN, V and WN. So these 6 pins are coming as a PWM from my microcontroller. Coming back to the power supply pin, VP1 and like VN1, these are high side voltage supply and low side voltage supply. So this is 15-volt input that is there. So this is the way, like you are understanding one by one each and every pins. Let us talk about other parts. We have fault signal output terminal. So if there is a fault in the IPM, then it will go low, and this is how you will understand, okay, my IPM is in faulty condition. If you have short circuit trip voltage, so short circuit is there because of high current, high load current or something, then this is the pin which will detect short circuit. We have VNC. So VNC, this is one more pin and one more pin, so only one of them has to be grounded. Okay, so you can see we have connect only one VNC terminal to the system ground. We have temperature output. So you can connect it to your ADC pin so that you can see what is the temperature of your IGBT. Okay, so let us talk about that in the circuit. So what we have VNC pin. So 2 NC pins are there, 1 and 2. So one of them is grounded. We have like fault output is pin. So fault output pin is going to go to my microcontroller. So when it goes low, what will happen? It will be telling you that the IC is in faulty condition. We have seen pin for short circuit protection. So you can see these 3 lines are taken here in the comparator, and this comparator is going to like compare through the voltage reference, which is 0.526 volt, and then this is how it is going to come here, and this is the like a PNP type transistor like driver, and this is how it is going to drive the circuit, and this CN is going to get connected at this particular place. Understood? So this is how short circuit protection will be taken care of. Understood? Then we have VOT, that is your temperature sensor output. So VOT sense will go to your temperature sensor into the microcontroller board. Let us talk about other pin. So other pin, you can see we have NW, NU and NV. So these are actually U, V and W phase of IGBT gate driver emitter N side. Okay, and this is the motor terminal U, V and W phase. So U phase, V phase, W phase, this is going to get connected to the motor U, V, W phases, and this is how it is going to be P, that is your DC link positive terminal, that is nothing but your high voltage terminal, which will be taking, let us say, 300 volt or 400 volt, you can put it. So basically you convert your AC voltage to DC form by putting one bridge rectifier, like so. This will be my bridge rectifier, and after that you send it to your DC link capacitor and point P. So put a DC link capacitor here with one like a filter capacitor, and then send it to your P. All right, so now I hope like you have a good understanding about this particular system circuit that we had designed. So like we have VUFB, VUFB, VVFB and VWFB. Similar to that, we have input PWMs. We have output terminal connected to the mic, like motor. We have current sense resistor connected here. Then we have comparator to short circuit protection, and we have fault signal outputs and everything. Going back to the next pages, we have like a current sense amplifier for U, V and W phases. So this is NU, NV and NW is coming up here, and a voltage reference is generated from 5 volt. So this 5 volt is generating 2.5 volt voltage reference, and this is buffered here, and this is like acting as the input to this particular thing. And make sure these particular grounds are actually coming from your like NU, NV, NW, those current sense resistors were there, those grounds are coming here. Okay. Similar to that, we have CAN transistors, CAN transceiver. So this CAN transceiver is coming from your microcontroller after this voltage level shifter. So this voltage level shifter is giving you 3.3 volt signal converted to 5 volt signal, and this 5 volt signal CAN TXD, CAN RXD is going to get converted to your CAN high and CAN low. We have DAC A, DAC B output for some DAC purpose or something like that. Coming back to the PWM signals, so PWM, see 1A, 1B, 2A, 2B, and 3A, 3B. These 6 PWM signals are there that is going to get, like buffered and voltage level shifted, because this is 3.3 volt and this is 5 volt. So this is going to get converted to 5 volt levels and then go to your P side, high side gate driver and low side gate driver. Okay, so high side gate driver HVIC and low side gate driver LVIC. Similar to that, we had fault signal. So fault signal was coming here from the IPM side and going to go to my microcontroller for faulty conditions understanding. Okay. Moving to the next part, this is my microcontroller system. So this microcontroller system, you can see we have proper pin configuration for analog side. Okay, so we have voltage monitoring of 15 volt, 3.3 volt and 5 volt. Then we have temperature sensor monitoring separately. We have this temperature sensor monitoring from IPM. We have current sense for U phase, V phase, W phase. Then we have one potentiometer connection. We have DAC output here. Okay. Similar to that, we have here PWM pairs. So you can see 1A, 1B, 2A, 2B, 3A, 3B, all are there. Then we have deep switches, user push buttons. We have LEDs that is connected for various other applications. Now communication interface, if you see, we have CAN RX and TX, that is CAN communication, and I2C communication is also there. Okay. Then we have the programming method, that is JTAG programming method. So JTAG is connected through this TMS, TCK, TDO, TDI. And we have one reset switch. So reset will be used to reset this particular microcontroller externally. All right. And power supply, decoupling capacitor and everything, you can see we have VDD MCU, VDD IO, that is, this is 3.3 volt, and this VDD will be actually taking the power supply from inside. Okay, so this will be taking from here, which will be 1.2 volt. So you just need the external decoupling capacitor that is given here. Then what we have done is we have put analog voltage here, VDD A. So VDD A is here after decoupling capacitors, and we have reference voltage for ADC, that is also same as VDAC reference. Okay, so this is also 3 volt. We have put external connector as well for all the PWM signal as well as temperature sensor and faulty signal. Okay, so this can be also used, or this particular board can be helping you to use external IPM evaluation board or something. Okay. Similar to that, we have discrete part. So discrete part, we have audio buzzer, we have potentiometer, we have EEPROM interface through I2C. Then we have LEDs 1 and 2. We have voltage measurement like voltage monitoring 5 volt, 3.3 volt, and V in A, this is nothing but your 15 volt monitoring. Okay. And all these three are going to go to your ADC pin, as just now I told you. Similar to that, we have temperature sensor, onboard temperature sensor one, I have put it, and then we have deep switches here, and we have one push button as well. Okay. Coming back to the power supply. So power supply, as you can see, what we need is we need to have a power supply connector which can be connected as 15 volt, or we can have a 15 volt adapter as well. And this 15 volt adapter will be passing through the fuse, which will be renamed as V in A. This V in A is going to get come here and then get converted to 5 volt 2 amperes. This 5 volt 2 ampere will be again get converted to another voltage level, which will be 5 volt to 3.3 volt for microcontroller purpose. Okay, and this this will be monitored through this particular orange LED, and 5 volt will be monitored through this particular red LED. Whenever this reset goes low, what will happen is it means this particular IC is in faulty condition. Okay, so that means this particular LED will not glow and you will see 5 volt is not working. And this is one reference voltage IC. So voltage reference IC has been converted from 5 volt to 3 volt for your DAC voltage reference as well as ADC voltage reference. So now I understand that you have a complete understanding of this particular circuit that we had designed. Okay, so this is my microcontroller part. This is my like voltage reference, I mean voltage buffer parts. So this is buffers 1, 2 and 3 as well as voltage translator parts, right? And then we have current sensing here, like I mean current sense amplifiers, and then this is my main IPM circuit design. So if you do have any questions or you want to utilize some other IPM for your design purpose, like I have used for like 600 volt 5 ampere current rating IC, you want to use, you can use like L series, or like I have used S series, right? Then L series, M series, X series is there, or W series is there. So whichever series you want to use, you can use. Circuit will be exactly same, just the power rating will increase. Okay, so this is how it will work out. Alright guys, if you have any questions, you can put down your questions in the comment box and we shall be able to answer you out. Thank you.